Let us continue thermodynamics. In the thermodynamics, second law of thermodynamics introduces the term delta S. This delta S total. This delta S in the sense entropy change. This delta S total is equal to what in the sense delta S system plus delta S surrounding. Delta S total is equal to positive for spontaneous process. Sorry. So, for spontaneous process, how the randomness will be there in the sense randomness goes on increases. Randomness goes on increases. Randomness goes on increases for which process in the sense for spontaneous process for which delta S total is what in the sense positive. Randomness increases in the sense delta S total is positive. Sorry. For non-spontaneous reaction, opposite we can take. For equilibrium, what about for equilibrium? That we'll see. Equilibrium in the sense forward reaction should be there, backward reaction should be there. Forward reaction, backward reaction. How the rate of forward reaction and rate of backward reaction will be there, that we'll see. Rate of forward reaction and rate of backward reaction. Rate of backward reaction. How rate of forward and rate of backward will be there for equilibrium in the sense equal. Rate in the sense velocity of reaction, speed of reaction we can say. So in the forward, suppose randomness increases. In the sense, in the backward randomness will decrease. This randomness will be cancelled by this randomness. Therefore, what is the change in randomness? What is the change in entropy? Zero. Therefore, for equilibrium, we can say change in entropy is zero. We can say. Sorry. Now, from second law of thermodynamics, we are getting the thermodynamic term delta S total. This delta S total in the sense entropy change for system and surrounding. Both we have to consider. System delta S we have to consider. Surrounding delta S we have to consider. Then only we can say, then only we will get delta S total. Using delta S total, we can say whether the process is spontaneous or non-spontaneous or equilibrium, we can say. So, now, in the thermodynamics, another manner they started to thought. In what manner in the sense? Is there any thermodynamic term which considers only system and describe and give criterion for spontaneity? Like this they started to think. Then they introduced another thermodynamic term that is called Gibbs energy. Gibbs energy. For Gibbs energy, what is the symbol means capital G? That is equal to what in the sense H minus Ts. H minus Ts. How do we say H is equal to U plus PV? Like that, this Gibbs energy is treated like this. In the Gibbs energy, what are the terms involved in the sense capital H? This capital H is called enthalpy. This enthalpy is the term introduced by first law of thermodynamics. Then this S is called entropy. S is called entropy. Entropy is the term introduced in the second law of thermodynamics. T is called temperature. So, first law of thermodynamics, thermodynamic term, second law of thermodynamics, thermodynamic term, and temperature, these three together taken as another thermodynamic term that is called Gibbs energy G. This Gibbs energy is a state function or path function, we'll see. Enthalpy is a state function, temperature is a state function, entropy is a state function, therefore Gibbs energy also state function set. So G is equal to H minus Ts. For what sake G is introduced means, for what sake this G thermodynamic term is introduced? In order to say criterion for spontaneity by considering only system. What about this delta S? This delta S says criterion for spontaneity by considering system and surrounding. If only system, if thermodynamic term considers only system to describe criterion for spontaneity, then it will be easy. So in order to make it easy only, this gibbs energy is introduced. Okay, let us see whether it is considering only system to describe spontaneity or not. We will see. Okay, sir. Now we will take a change in gibbs energy. We will take change in gibbs energy delta G is equal to change in enthalpy delta H minus keep temperature constant, take change in entropy delta S. Okay, temperature we kept constant. Temperature is kept constant in the sense at a given temperature we are taking. So delta G is equal to delta H minus T delta S. Now main thing is what means this thermodynamic term should consider system only. For therefore system will write delta G for system, then delta H for system, temperature is constant, delta S for system. Everything we will take for system only we will take. So next we will see system and surrounding. If system is if system absorbs q amount of heat at constant pressure, if the system absorbs q amount of heat at constant pressure, then surrounding will lose same amount of heat, isn't it? System is absorbing q amount of heat at constant pressure means surrounding will lose same amount of heat at constant pressure. If system releases q amount of heat at constant pressure, then surrounding absorbs same amount of heat at constant pressure, isn't it? System absorbing heat means from where it can absorb, from surrounding. System liberates heat means to where it will liberate, to the surrounding, isn't it? Therefore here amount of heat involved, here amount of heat involved, magnitude is same, but they are opposite. Opposite in the sense system absorbs means surrounding releases, surrounding absorbs means system releases, therefore opposite sign we are giving, sir. Next we will take delta S surrounding. We will take delta S definition is what in the sense q reversible by T, Carnot cycle. From Carnot cycle we got delta S is equal to q reversible by T. Sorry. So delta S surrounding is equal to q reversible surrounding by T. Let us substitute this q reversible surrounding. Will substitute from here. This from here, if you substitute, what you will get means q reversible system sign will be minus by T. We can write q surrounding is equal to minus q system. Q surrounding and q system are equal but opposite sign. Therefore we will write like this. This minus sign will write q system is equal to delta H system. We can say delta H system because at constant pressure. So q system is equal to delta H system, we can say, by temperature. Okay. Therefore from this one and this one we can say delta H system is equal to minus T delta S surrounding. Okay, this delta H system is equal to this minus T delta S surrounding. We can get this delta H system. Let us substitute here. Substitute in this place. Delta H system here is there. No, here you substitute. Okay, so we will write delta G system is equal to minus T delta S surrounding minus T delta S system. Okay, this delta H system we have substituted here. That delta H system we have substituted here. Therefore, we are getting delta G system equal to here minus T delta S surrounding minus T delta S system. Like this we will get. Okay, like this we got. Next, this delta G system is equal to minus T. If you take outside, what will be there means delta S system plus delta S surrounding. Okay, then we can say delta G system is equal to minus T. This delta S system plus delta S surrounding, we can say delta S total. Delta S total we can say. So delta G system delta G system is equal to minus T delta S total, we can see. Okay. So delta G system is related to what in the sense temperature and delta S total. Okay. Now we will say criterion for spontaneity. Now for spontaneous process, for a spontaneous process, delta S total says delta S total is what in the sense positive. Delta S total is positive, we can say. For spontaneous process, what is the delta S total means positive. This positive we will substitute here. We will substitute here. So for spontaneous process, delta S total is positive. Temperature is in Kelvin scale. Temperature always positive. Therefore, this is positive, this is positive. Therefore, delta G system is what? Negative. So we can say delta G system negative, we can say. So for spontaneous process, delta S total is positive, therefore delta G system is negative. So now using this Gibbs energy, saying the criterion for spontaneity is easy, because this Gibbs energy considers system, whereas entropy considers total. Therefore better to use delta G instead of delta S. So for spontaneous process, what is the criterion means delta G system is equal to negative. So now non-spontaneous process means take opposite. For non-spontaneous process, here negative, here positive. Okay, it is non-spontaneous process. Now we will say equilibrium we will take. So for equilibrium in the sense, this delta S total is how much in the sense 0. Delta G system is how much in the sense 0. Okay. So for equilibrium, this delta S total, for equilibrium, delta S total is what in the sense 0. Delta G system is what in the sense 0. Sir, it is the criterion for what in the sense spontaneity. So what is the criterion for spontaneity that we got? Okay. So to say criterion for spontaneity, better to use what in the sense delta G system. Why delta G system we have to use means delta G system considers first law of thermodynamics and second law of thermodynamics. Therefore, and also delta G considers only system. Therefore, better to use delta G system to say the criterion for spontaneity. Set. Then temperature spontaneity. Is there any relation? That we will see. Temperature and spontaneity. By changing the temperature, spontaneity will be on changing the temperature, spontaneity will be changing or not. That we will see. Temperature and spontaneity relation that we will see. Okay. So now we are going for a temperature spontaneity relation. So spontaneity and temperature relation that we will see. Okay. Now we will take a for this delta H system we will take, then delta S system we will take, then delta G system we will take. Okay. Now for a given process, for a given system, this is negative we will take. That means exothermic. That means exothermic in the sense favorable. Why favorable? Because we need not supply any heat. Okay. Delta H system we have taken exothermic. It is favorable we have written. Why? Because we need not supply any heat for this system. For this process, we need not supply any heat. Then delta S system we will take. This we will consider positive. That means entropy rises. Entropy rises means randomness rises. Entropy rises in the sense this is favorable. Entropy rises in the sense it is favorable process. Entropy decreases in the sense unfavorable process. Sir, with respect to entropy, it is favorable, we said. Net in the sense delta G only we have to think. Okay. Now delta G should be negative, then only the process is spontaneous. Otherwise, no. Delta G is negative, then only process is spontaneous. Now, at what temperature? At what temperature delta G can be negative? Then the process is spontaneous. For which, what is the formula we have to use? Delta G system is equal to delta H system minus T delta S system. It is a formula we have taken. Now, delta H system is a negative Z. Okay. Delta S system is a positive Z. Now, delta G system should be negative for a spontaneous process when the temperature is, at what temperature? At what temperature delta G system can be negative? Then the process is negative. At what temperature? Shall we use high temperature or low temperature or at any temperature? What shall we say, do it for this? If the system comes under this category, that means system comes under exothermic. In the system, delta S is positive. In the system, delta S is positive. For such a type of system, the system can be spontaneous if the temperature is, very high or moderate or low or very low, or what, or any temperature. What shall we take? Okay, what shall we take in the sense, at all temperatures, delta G will be negative. That means process will be spontaneous. For such a type of system, temperature can be whatever, the process, the system will be spontaneous system. The process will be spontaneous process, we can say. Okay, next, now we will take a delta H. Delta H of the system is a positive. That means endothermic. Endothermic means unfavorable. Why unfavorable? Means because we have to supply heat. So, then delta S system is a negative. That means randomness decreases of the system. For the system, randomness decreases. That means it is also unfavorable. Okay, randomness rises means that is favorable. That is that process is favorable. How exothermic is favorable, we are saying like that, for this entropy, in the sense randomness should rise. Randomness decreases in the sense unfavorable only. So, now delta G, how delta G will be there? How delta G will be there, that you will see. Delta G can be, positive or negative. That we have to understand. Delta G can be positive or negative. At what temperature? That we will see. At what temperature delta G can be negative such that the process can be made spontaneous? For this system, delta H, how it is there? Unfavorable for spontaneity. Delta S also unfavorable for spontaneous. Now, by changing the temperature, can we make the process as spontaneous? That we'll see. So, by changing the temperature, if you make delta G as negative, then the process can be spontaneous. Is it possible or not? That we'll see. Now, we'll take the formula delta G is equal to delta H minus T delta S. This delta H is positive. This delta S is negative. Temperature is positive term, we know. Now, substitute any temperature. Can we make delta G as negative? If delta G comes as negative, then the process will be spontaneous. Temperature, whatever the temperature you need, you can take. If you want low temperature, take it as per that, high or low or medium, very high, like this, anything you take. If you want to zero, if you want to take zero, take zero. Like this, you mention the temperature. Then such that delta G can be negative. Now, is it possible? Sir, at any temperature, at whatever the temperature you see, delta G cannot be negative. Only possibility for delta G is positive. Then the system will be only non-spontaneous. At whatever the temperature, the delta G of the system will be positive only for this case. When delta H is positive, delta S is negative, delta G can be only positive for whatever the temperature. There is no other way. By changing the temperature, this system, this process, we cannot make it as spontaneous. This process can't be make us spontaneous by changing the temperature. At whatever the temperature, the process will be non-spontaneous only. Sir. Now, delta H of the system is negative. That means exothermic. That means favorable. Sir. Delta S of the system is a negative. Negative means randomness decreases. That means unfavorable. No, such a type of system we will take. Okay, we have taken the system in which delta H is favorable, delta S is unfavorable, such a type of system. Now, delta G, can it be negative or can it be positive with respect to temperature? Which temperature if you take, delta G can be negative, or which temperature if you take, delta G can be positive, that we will see. Now, this delta H is negative, it is negative. Delta S is negative. So if temperature is what, such that delta G can be negative, that means which term should be dominant, delta H or T delta S, that we will see. So delta H and T delta S, how it should be there? How it should be there? Which term should dominate? In the sense, delta H should dominate. If delta H is greater than T delta S, then delta G will be negative. This is possible if temperature is what you think it. Then we'll see here. In this case, delta H is not dominant. In this case, delta H is not dominant. So it is possible at which temperature you see. So this is possible when the temperature is low. This is possible when the temperature is high. Okay. Therefore, if you take low temperature, the process can be made spontaneous. If you take high temperature, the process can be made non-spontaneous. So one is favorable, another one is unfavorable, means by changing the temperature, we can make the process as spontaneous. Okay. So one is favorable, delta H is favorable for the process, delta S is unfavorable for the process. Now we will make the process spontaneous by changing the temperature here. So here, if we keep low temperature, the process can be spontaneous, we can say. Sir, next, this is positive, endothermic, unfavorable. This is unfavorable. This is positive. Randomness increases, favorable. It is favorable. So one is unfavorable, one is favorable. Now delta G will see. One possibility negative, another possibility positive. So when that we will see. Here how delta H and T delta S should be there. Here also how should be there, which should dominate. Then how the temperature should be there. How the temperature should be there for both cases. Okay. So now we'll see here. Delta H is positive. Delta H is positive in the sense which should dominate means T delta S should dominate here. Here delta H is positive means delta H should dominate. If delta H is dominating, delta G is positive. Then here low temperature, here high temperature. So it is unfavorable for the system, it is favorable for the system. Now we can make the process spontaneous by keeping high temperature. Okay, sir. So one is favorable, another one is unfavorable, means by changing the temperature, we can make the process spontaneous. If both are unfavorable, then we cannot make the process as a spontaneous by changing temperature. If both are favorable, then the process will be spontaneous at whatever the temperature set. So what is the relation between temperature and spontaneity that we have seen? Okay, temperature and spontaneity relation, we got an idea. Next, we will say delta G. We'll say delta G in terms of temperature. We'll see delta G in terms of temperature. Okay. Now we will take Gibbs energy. Gibbs energy is equal to H minus Ts. Okay. Gibbs energy is related in terms of enthalpy, temperature, and entropy. Now we will see change in Gibbs energy. Change in Gibbs energy for infinitesimal change. Infinitesimal change means dg we have take dg is equal to dh, temperature will keep constant, ds entropy will keep constant, dt. Okay, temperature is constant means tds, entropy is constant means sdt. Okay, like this we have written. Next we will see first law of thermodynamics. H is equal to u plus pv. H is equal to u plus pv. Now infinitesimal change, therefore dh is equal to du plus pdv plus vdp. How we got this means keep pressure constant, change the volume. Keep volume constant, change the pressure. Okay, this dh, this dh substitute here, substitute here. Okay, so dg is equal to substitute dh. Dh is how much? Du plus pdv plus vdp minus tds minus sdt. Okay, next let us substitute du. Let us substitute this du. Mathematical form of first law of thermodynamics is what? In the sense du is equal to q plus w. Okay, then du is equal to q is what? In the sense second law of thermodynamics says ds is equal to q reversible by t. That q reversible substitute here, therefore tds. W is equal to minus p dv. Okay, w is equal to minus p dv, all for reversible process only. Okay, so du is equal to tds minus pdv. This du substitute here, therefore dg is equal to, in the place of du you have to substitute tds minus pdv. Remaining we will write, remaining is what? pdv plus vdp minus tds minus sdt. What are the common terms? Common terms are there, cancel it. tds we can cancel, pdv we can cancel. Then what is the remaining means dg is equal to vdp minus sdt, vdp minus sdt, that we can say. Now take temperature constant. You are taking temperature constant, then we can say dg at constant temperature is equal to vdp. Temperature constant means dt is 0, therefore dg at a given temperature is equal to vdp we can say. Okay, next this dg at a given temperature is equal to ideal gas formula, volume substitute. So nRT by p, nRT by p. Okay, nRT by p we have substituted in terms of volume. It is for infinitesimal change. For the entire change, in the sense take integration, take integration, temperature is constant. Okay, so initial pressure is what? In the sense p1, while Gibbs energy is g1. Final pressure is p2, while Gibbs energy is g2. Okay, like this we have taken. Next step. Now dg on integration, dg on integration gives what? In the sense g. dg on integration, dg on integration gives g. Lower limit is g1, upper limit is g2, then equal to this nRT we will write. Then dp by p on integration gives ln p. Here lower limit is p1, upper limit is p2. Okay, substitute upper limit g2 minus g1, then nRT substitute upper limit ln p2 minus lower limit ln p1. Okay, then g2 minus g1 is called delta g, that is equal to what? We can say means nRT ln p2 minus ln p1 is called ln p2 by p1. Okay, now we said delta g in terms of pressures, delta g in terms of pressures we said. If we want delta g in terms of volumes, then pressure is inversely proportional to volume. Therefore, we can say delta g is equal to nRT ln v1 by v2. v1 by v2 we can say. Okay, so we said delta g in terms of, delta g we said in terms of what? In the sense volumes. Here delta g in terms of volumes, here delta g in terms of pressures we said. Okay, next we will take here we will take this formula. What is that formula? Means delta g is equal to vdp minus sdt is there. Now that formula we will take. Now dg is equal to what? In the sense vdp minus sdt, that formula we will take. Now we will take pressure is constant, pressure is constant we will take. In the previous case temperature constant we said, now we will take pressure is constant. Therefore, we will get dg at constant pressure is equal to minus sdt. We will take it minus sdt. Okay. Next we will see what in the sense this dg at constant pressure by dt at constant pressure is equal to minus s. Minus s in the sense entropy we can say. Okay. So now Gibbs energy relation will take Gibbs energy is equal to H minus Ts, enthalpy minus temperature and entropy. Now we will substitute this minus this S we will substitute here. Okay. So G is equal to H plus T into minus S. This minus S you substitute. Therefore G is equal to H plus T into this dg by dt at a constant pressure. Okay. We got this one. Next we will see change in Gibbs energy. We'll see. So change in Gibbs energy, that relation will take, that is delta G is equal to delta H minus T delta S. This relation will take. That means change in Gibbs energy delta G, change in enthalpy delta H. This temperature is constant. Change in entropy delta S. Okay, like this we have taken. Next step, what we will do in the sense, next step, delta G is equal to delta H plus T into minus delta S. Minus delta S we have written. Okay, sir. Next step you see, this is delta G, this is delta H plus T. Now S is called what? Entropy is called what? Entropy is this. It is the entropy. Okay, this is the entropy. Okay, this change in entropy we want. Change in entropy is what in the sense? Change in entropy in the sense. Now change in entropy in the sense delta G we can say. Change in entropy is this. This change in entropy delta S, if we take, G will become delta G. G will become delta G. Okay, at a given pressure. So change in entropy in the sense G will become delta G. Therefore delta G we have written here. Now here delta Rg is equal to delta Rh plus T into d by dt into delta Rg at a given pressure. This equation is called what in the sense? Gibbs-Helmholtz equation. This is called a Gibbs-Helmholtz equation, we can say. Gibbs-Helmholtz equation, we can say. So what is delta Rs? So what is delta Rs? Okay, this minus delta Rs is equal to what in the sense? This one. Minus delta Rs is equal to this one, we can say. Okay, so this is about thermodynamics theoretical part.